Hello, everyone. Hope you're having a good time here at 2021 Health Informatics Conference. Thank you for being here. My name is Vishakha Sharma. I'm a principal data scientist at Roche. And today I will be presenting on the topic natural language processing assisted healthcare data curation. To tell you a little bit about Roche, it is a 125 years old company with headquarters in Basel, Switzerland. It has two main business divisions, diagnostics and pharmaceuticals. It is number one in vitro diagnostics and a leading provider of cancer treatment worldwide. Within diagnostics, we are a team of called Roche Information Diagnostic Solutions. Our primary focus is Navified Decision Support Portfolio, where we are working mainly in oncology. So Navify Tumor Board is a cloud-based workflow product that securely integrates and displays relevant aggregated data into a single holistic patient dashboard for oncology care team to review, align, and decide on the optimal treatment for the patient. The clinical decision support apps ecosystem is secured and fully integrated with Navify Tumor Board. We have three clinical decision support apps, Navify Guidelines, Navify Clinical Trial Match, and Navify Publication Search. So for a patient, a large number of data points get generated along their journey. For example, genomics, pathology, radiology, and their clinical data. The goal here is to navigate through the complexity of a patient's journey and generate a longitudinal view by unlocking these data sources. And for a more comprehensive view, unlocking unstructured data is very important because a lot of time this has diagnostics and treatment information. These data allow us to do clinical decision support and population analytics. For this talk, I'm going to focus on the unstructured text data in the pathology and radiology reports. And here is an example of, a pathology report. So pathology reports are very diverse. They have jargons, tables, key value pairs, and handwritten notes. And in a lot of cases, what we see here is basically when a sample report gets reviewed by a pathologist, it looks like this, right? So how many of you have seen something like this? This is handwritten text. And if you read closely, you can see they are talking about tumor site, tumor staging, ICD codes, and a bunch of other things. All of these annotations make this report extremely valuable, but the challenge is how do we extract all of this information? So it is quite clear that looking at these reports, that along with NLP, we will need optical character recognition, that's OCR, to efficiently extract information. So what is NLP? NLP is a field of artificial intelligence that helps computers understand, interpret, and manipulate human language. NLP draws from many disciplines, including computer science and computational linguistics. In its pursuit to fill the gap between human communication and computer understanding. What is optical character recognition? OCR is the recognition of printed or written text characters by a computer. And we need NLP with high accuracy, specialized for medical data, with minimized time to train models, and that can be extended for new content types. We need OCR with high accuracy and ability to retain document structure like tables, lists, and paragraphs. We had a bunch of requirements from tools and services that could help us achieve this task or needs like scalability, compliance, low cost, ability to run on-prem or in the cloud. The success of NLP approaches heavily depends on being able to understand the domain. And as a first step, we want to identify named entities from the domain-specific documents. These entities are highly specific to the use cases that we are trying to build for our Navify product portfolio. So healthcare data, as I said, is extremely heterogeneous and complex and requires high quality labeling data and domain expertise. And that can be very expensive and time consuming for any organization. So at Roche, we have extracted more than 45 oncology entities from pathology reports. And here are a few examples of a surgical pathology report from patients diagnosed with lung, breast, and colon cancer. So the highlighted text shows the entities of interest and its associated labels. The first example shows the diagnostic information of a lung patient, lung right upper lobe lesion, wedge biopsy adenocarcinoma moderately differentiated. So when lung is the location and right is the laterality, wedge biopsy is a procedure, and 2.5 centimeter is the size of the tumor, and it says surgical margins are not involved. The second example shows a microscopic description of a breast patient. Histologic type is invasive ductal carcinoma with metastatic features, areas of sarcomatoid carcinoma. Histologic grade is not mentioned, and overall grade is 3. In this sentence, we have labeled invasive ductal carcinoma as cancer type and sarcomatoid carcinoma as cancer type, as well as 3 is labeled as grade. So the last example shows the clinical data and pathologic diagnosis of a colon patient. And basically, cancer location here is ascending colon mass. And final diagnosis says a right colon with appendix hemocolectomy. And there are 2 adenocarcinomas which are at proximal ascending and distal ascending colon. So if you see this example, you see multiple mentions of type, cancer type, localization, and procedures. And our approach has been, as first step, categorizing the content broadly as possible. And this helps us achieve high recall with entity extraction. And we then, in next step, drill down into achieving higher precision by mapping entities to standard concepts. So before I discuss like how we evaluated OCR, I want to reiterate like what is OCR, right? Optical character recognition basically is a technique that is used to convert documents, images to machine readable text. Our goal has been, as you can imagine, to make sure we consistently convert PDFs to text for pathology or genomic documents. To evaluate the performance of the OCR system, we used a combination of metrics starting with character error rate, which is nothing but the minimum number of operations required to transform a reference to output. Then we evaluated based on the word error rate, which is the number of words substituted, deleted, or inserted from reference to output. Evaluating word error rate poses some challenges like spacing and length of word sequences. To overcome this, we used the bag of words error rate, where instead of looking at words, you look at bag of words. So each of these metrics was measured against a bunch of OCR system parameters, like if the document is a text or an image, or the page segmentation mode, which tells us the system if the document has a single character or a block of text or tables, etc. And the last is the erosion and the scaling factor. So overall, based on the metrics against our ground truth, we landed on a set of value parameters that perform well on our data. So after we applying the OCR on PDF documents, we used NER, which is named entity recognition. And it's a subtask of information extraction that seeks to locate and classify named entity mentions in unstructured text into predefined categories such as tumor site, primary tumor, etc. And we trained our model using CNN by LSTM. That's a novel neural network architecture that automatically detects a word and character level features using a hybrid bidirectional LSTM and CNN architectures, eliminating the need for most feature engineering. And it has been published already in 2015 by Jason Chu. BERT stands for bidirectional encoded representation, from transformers. So unlike recent language representation models, BERT is designed to pre-train deep bidirectional representation from label text by jointly conditioning on both left-right context in all layers. And this work has been published by Lee in 2019. BioBERT is the first domain-specific BERT-based model pre-trained on biomedical domain Corpora. It used PubMed abstracts and PMC full text articles, I think for almost 23 days on 8 NVIDIA V100 GPUs. And the work got published by Lee in 2018. So we trained our models using CNN, BILSTM, and BERT models to basically extract these 45 oncology-based labels from pathology reports using Spark NLP. So I talked about OCR, named entity recognition, but with just these two approaches, we cannot structure unstructured text. So what is entity resolution? Entity resolution means removing duplicates, normalizing data, disambiguating records that correspond to real world entities across and within data sets. So we have been looking into approaches which combine clinical embeddings and named entity resolution to pick appropriate terminology concepts. Similar to named entity recognition, entity resolution models are per terminology ontologies like ICD-10, RxNorm, SNOMED, etc. So if you look at this example, let's say for colectomy, there is a specific code. And if we are using a particular colectomy, which is a procedure, then we get a separate code for that specific term. So this is how, like I have discussed the techniques used, but let's talk about the workflow and the process, right? So what you see here on this slide is a complete workflow that we have adapted. On the left-hand side, I show how the model is built. And on the right-hand side, we see how the model is served and consumed. So there are many elements here for building the models in an automated manner. We stuck with old-fashioned like Jenkins, which we use for orchestration. Another choice we made was to stick with Jupyter for exploratory data analysis and even run it in the pipeline. To parameterize Jupyter, we use Papermill. Our NER OCR implementation is Spark NLP based. We use MLflow to track performance of each run along with recording the artifacts. This gives us the ability to compare, pull, and deploy artifacts from any run. We deploy the latest model that reaches the threshold performance as APIs, which then can be consumed by downstream applications. So this is our sandbox. Getting to product is a little more manual since we are in a regulated environment. So having said that, let me conclude on the section by saying that, NLP has been a journey for Roche. We will work towards expanding to more domains and automating this information as much as possible. Thank you. And we are hiring. Any questions, feel free to ask.
Thank you very much, Dr. Sharma. It's very interesting to see that we can make in NL natural language processing for medical documents. I want to know if you take this decision of the input of the Navi is PDF when we have some institute that could have interoperability structure like CDAs or something like more structured informatics, medical informatics information for the input for we more specific. Why you choose PDF and need to understand what the PDF are contracting when we have some different terminologic in interoperability standard like CDS for structured medical data?
Yes, that's a very good question, right? So I think I would say we are moving like we do EMR integrations with different hospitals, right? But I think all the hospitals, I think they still don't have a proper synoptic templates when they have to report on pathology or radiology reports. So most of during our integrations, we get PDFs as attachment, and based on different hospitals, the structure and the format is very different. So if we want to extract any specific entity, our models have to generalize enough so that we can basically extract information from these different formats of PDF documents, which are coming from different hospitals in different formats.
Right, I assume that in the Hospital Italiano, we have thinking about a similar product that we help to codification with ICD-10 documents for inform to the Minister of Health of Argentina. We think that because the most institutions in Latin America don't have so much standards about how structured information, and think with PDF input can be helped for that. I wanted to know too if this type of tools are only in English or are moving to other language for understand the medical terminology.
Yes, absolutely. So for today's talk, I focused on the English language, but we do have initiatives which are going on in non-English language, especially in German, and also the technology is there that can handle even Spanish language today. So I think that capabilities exist, and we just have to try and see what could be the good performance of that model and how successfully we can extract that information. I think, Julian, you're on mute.
Sorry. I want to ask you if Navify, that is a CDSS for support different, for support oncology, how do you integrate in the workflow of the clinics that have different HIR? Are you integrated with the commercial solutions in USA?
Yes. So we do work outside US also because we are a global worldwide company, and the hospitals, they are spread across different global regions. So that is not like a concern for us. I think we do have hospitals in Spain that we are trying to integrate. We do have hospitals like Taiwan, and also Southern America. So basically, that is not the concern for us because of our global worldwide presence.
Great. Thank you very much for your presentation. That was very interesting.